Hey everybody. After we were working on today's classwork, several students asked if I would create a quick video to review the material that we covered. So I wanted to put this together. It follows right in with the assignment that we're on. So I'm going to use the same language used in the assignment. I pulled these spinners from the assignment, and let's jump into how we would find the probability of a certain event. So this first spinner, I'm going to call this SP1, spinner 1. Spinner 1 is divided into 5 equal size parts. It's important to know that they're equal size because that means the probability of any one part is the same as every other part. And the language used in their description of these parts was there's a white section, there's a section they call not striped, and then the sections they call striped. For the not striped, there are 2 of those. For the striped, there are 2 of those. So to make sure we recognize that there are 2 of each of those, we're going to use some additional notation. We're going to call this not striped sub 1 and not striped sub 2. So we have 2 not striped sections. We're going to do the same thing here, striped sub 1 and striped sub 2. For the spinner with the letters on it, which we're going to call spinner 2, there are 3 sections, again, all equal in size, labeled A, B, and B. And just like with the first spinner, since B appears more than once, we're going to use a sub 1 and a sub 2 to show that those sections appear more than one time. So there's our basic layout. Now what we want to do is we want to ask ourselves, okay, if a certain event, if there was a question of the probability of white and A, if that's what we were trying to figure out, what's the probability that you'd spin the first spinner, it would land on white, you'd spin the second spinner, it would land on A. So to do that, there are 2 ways we can do it. I'm going to show you the why it works, and then I'll show you a shortcut. Let's start out with the why it works. To understand the why it works, we want to look at the probabilities of each of these things happening. So I'm going to look at my 2 spinners, spinner 1 and spinner 2. It is possible on spinner 1 that I could spin white. So my spinner lands in the white section, just like it shows here. Then I spin spinner 2, and it's possible that when I spun spinner 2, it landed on A. So this is one possible occurrence. White on the first spinner, A on the second. It's also possible that I could spin white on the first spinner and then get B on the second spinner. I'll pick the B sub 1. So if the spinner here stopped in this section. And it's also possible I could spin white on the first spinner and have the second spinner, right where they show it here, B sub 2, this second wedge marked B. So notice, for white on the first spinner, there are 3 things that can go with it on the second spinner. All right, let's go back to the first spinner. Let's say instead of white, it landed on the non-striped section. And we'll pick non-striped section 1. So I spin it, it ends up over here on non-striped section 1. What about spinner number 2? Well, it could land on A. It's also possible that for non-striped section 1, the second spinner could have landed on B1. And it's possible that it landed in non-striped section 1 on the first spinner and landed in B2 on the second spinner. Hopefully you're seeing a pattern emerging here. It's also possible, let's just go around the spinner. It's also possible that this landed on striped section 1. I'm going to write that 3 times. And I think you're starting to see the pattern. I'm writing it 3 times because if it lands on stripe section 1 here, the second spinner could have landed on A. Or the second spinner could have landed on B1. Or the second spinner could have landed on B2. So again, we're going through and we're mapping out all the possible things that could happen. Okay, I went ahead and put in the next, I continued around the spinner, so we could land on S2, striped 2, and that could go with A, B1, and B2. We could land on non-striped 2 on the first spinner, and that went with A, B1, and B2. So now you can see that there are 5 possibilities with spinner 1, and each of those 5 possibilities has 3 possibilities with spinner 2, which means that altogether there are 15 possible outcomes. Well, that makes sense because there are 5 possible outcomes on spinner 1 and 3 possible outcomes on spinner 2. That's our shortcut way of knowing the number of things possible. If there are 5 things on the first one that can happen and 3 on the second one, that creates 15 combined possible outcomes. So then back to our original question, what's the probability of spinning white and A? White and A shows up 1 time out of the 15 possible. What about the probability of spinning white and striped? So here's white, can't be white and striped because white and striped are on the same spinner. That was a little brain vacation. How about white and B? Well, white appears with B1 and white appears with B2. So the chance of getting white and B are 2 times out of 15. All right, so what's the probability that striped could happen with A? Now we have striped twice, so we have 2 sections. So we had a striped one, so striped 1 happens with A once, and striped 2 happens with A once. So there are 2 places where you have a striped and an A out of those 15. Let's look at one more probability. What about the probability of not striped happening with B? Not striped 1 happens with B, so let me just keep track of them here. Here's 1 time it happens, not striped with B. Here's another time it happens, not striped with B. There's also a second not striped space right up here, so it happens again with B and again with B. There is a 4 out of 15 chance that not striped and B could be the results of the 2 spinners. So I said I would show you a shortcut for how we do this, and let's use this one for my shortcut. Let me give myself a little more room to write. So not striped, well, it happens twice on this spinner, twice out of 5 possible choices on this spinner, times B happens twice out of 3 times on this spinner. And when we multiply those together, 2 times 2 is 4, 3 times 5 is 15. That's how we get our probability. It's the product, answer to multiplication, out of the probability of the different events. So since there's a 2 out of 5 chance of not striped and a 2 out of 3 chance of B, we multiply those together, and the chance of not striped and B is 4 out of 15. So there's your quick review on probability of independent events. Now, if you want to continue watching, we'll do probability of dependent events. So next we're going to look at the probability of dependent events. Now recall that an event is dependent if its probability is affected by something that happened before. So let's look at this scenario. It says find each probability if you pick a card and do not replace it with a second card. Here the key idea is that do not replace it with a second card. So we want to ask ourselves, if we have a situation where we're picking one card, we're keeping it, and then having somebody pick another card, what's the probability of those events? So let's take a look at the first one they ask us. What's the probability of a black card, then a white card? So before we start, let's figure out the probability of each of those situations. What's the probability of just getting a black card? And the probability of getting a white card, if that's your first pick. So for each of them, it's going to be something out of 8, because there are 8 cards total. Of those 8 cards, 1, 2, 3, 4, 5 of them are black cards. 3 of them are white cards. Since all the cards are either black or white, we know that if we add the probability of the black cards to the probability of the white cards, we should get 100%, which is true. 8 out of 8 would be 100%. All right, so how about a situation where we draw a black card, we keep it, and then draw a white card? Drawing the black card, let's break this down. So the probability of drawing the black card we said is going to be 5 out of 8. We draw the black card, we hold on to it, which means the black card we selected, let's say it's this black card, is gone now. And it's time to select the white card. So now what's the probability that we'll pick a white card? Well, there are 3 white cards. However, the total number of cards has changed. It's no longer 3 out of 8. That's what it would be if we hadn't done anything else yet. But now, since that black card is gone, it's 3 out of 7. Just like with our independent probability, we get the total of these by multiplying them together. So 5 out of 8 times 3 out of 7. And you can, some students, it helps to visualize this, when you're multiplying fractions, you can think of this as being one great big fraction line, where you're multiplying the top number times the top number, and you're multiplying the bottom number times the bottom number. So the top number gives me 15, and 7 times 8 gives me 56. There is a 15, so the probability of a black, then a white, without replacing any cards, is 15 out of 56. Let's do one more. Let's do number 3. We'll go to the one below it. Is it the same probability? If it's black then white is 15 out of 56. Is white then black also 15 out of 56? Let's find out. We're doing the probability of drawing a white card, then a black card. Well, the probability of drawing that first white card, and we're back to a point now where everything's in the deck, there aren't any cards used up. The probability of drawing that white card is 3 out of 8. Then we take that white card and we keep it. We don't put it back in the deck. It's gone now. So what about the probability of drawing the black card? There are still 5 black cards, just like originally, but now there are only 7 cards altogether. So we've got 3 out of 8, and 5 out of 7, 3 out of 8, times 5 out of 7. I can think about doing the top times the top and the bottom times the bottom. And yes, there is the same probability. 3 times 5 is 15, 8 times 7 is 56. Still a 15 out of 56 chance. If you remember from our first video, we did the spinners. I said you can figure out that there are 15 possible because the first spinner has 5 and the second spinner has 3. So when you multiply those together, you get the possibilities. The same is true with our cards. When you first draw your card, there are 8 that you can draw from. And when you next draw your card, there are 7. Like our spinners had 5 and 3. Our cards, the first choice has 8. When you make your second choice, there are 7. That's where we get the number of possibilities, the 56 that we see on each of these. So that is how you do independent events. That was the first part of this video. And now this is how you do dependent events. The multiplying, the probabilities, the individual probabilities is the same. The only thing you have to remember with dependent events is when you get ready to do the second thing, make sure you have taken into account what happened first. In this case, when you pick the second card, make sure you took one away because when you pick the first card out, you kept it. All right, I hope that helps. If you have any more questions about this assignment or any of the assignments, please feel free to let me know. Thanks a lot.